Hello everyone, welcome back to Introduction to Petroleum Engineering. In this week we begin a major step in reservoir engineering, reservoir modeling. Up to now, we learned how to measure rocks and fluids using core analysis and well logs. This week, we learn how to combine those scattered pieces of information into one consistent subsurface picture, a digital reservoir model. Think of it as building a subsurface map that engineers can use to estimate in-place volumes, evaluate connectivity, quantify uncertainty, and prepare for the next step, reservoir simulation. Let's place week 9 inside the course roadmap. We have already covered exploration and appraisal topics, petroleum geology, geophysics, drilling, petrophysics, and well logging. Now we are in the development stage, where the key question becomes, how do we turn all of our subsurface data into decisions? Reservoir modeling sits right before reservoir simulation because modeling provides the static framework, structure, faults, layers, facies, and rock properties, while simulation later uses that framework to predict dynamic behavior such as pressure decline, water breakthrough, and recovery over time. This slide is the map of today's lecture. We will first define what reservoir modeling is and why we do it. Then we will talk about model planning, how to decide the purpose of your model, what data you need, and how to build a reliable database. After that, we walk through the practical construction workflow, building a structural framework, creating a grid, modeling facies, modeling properties like porosity and permeability, and finally ranking models and assessing uncertainty. At the end, we recap the key learning points and connect directly to next week's topic, reservoir simulation. Reservoir modeling is the process of building a detailed digital representation of subsurface geology that integrates geological interpretation, geophysical information like seismic, petrophysical measurements from logs and core, and engineering constraints. The goal is not to create a beautiful 3D image, it is to create a numerical model that can hold reservoir geometry and properties in a structured way. When this is done correctly, the model becomes a shared reference for geologists, petrophysicists, reservoir engineers, drilling engineers, and production engineers, because everyone is working from one integrated subsurface understanding. The static reservoir model, often called the geomodel, describes the reservoir before production starts. It captures the spatial distribution of rock types and their properties, such as porosity and permeability, across the reservoir volume. One of the most important outputs from a static model is a credible estimate of hydrocarbons initially in place, because that is the baseline for all later development decisions. This slide also reminds us that many real reservoirs, like the Gullfaks field offshore Norway, are heavily faulted. Faults can compartmentalize the reservoir, change connectivity, shift contacts, and create uncertainty. So a good static model must treat structure seriously, not as a small detail.